Hi. In this lecture, what I want to do is I want to talk about the role that randomness plays in performance. In particular, I want to think about the relative role of skill and luck, and we can think of luck as randomness. Now, a simple way to write this down would just be to say someone's outcome depends on two things. It depends on their skill, their ability, and it also depends on luck. It depends on, did things go the right way? Did the errors fall in their direction? Did the complexity unfold in a way that was beneficial to them? That sort of thing. And you can take any sort of domain, whether it's sports, law, politics, and you can say, well, that person's really good. They've got a lot of skill. Or you might alternatively say, oh boy, she has been so lucky. Everything's fallen her way. So just think about in normal language we do this. What would be nice to do is construct a model that helps us understand how much skill is there and how much luck is there. Now there's a book coming out by a guy named Michael Mauboussin, who works at Legg Mason, and he's a financial analyst. And what Michael does is he's taken a whole bunch of different domains and tried to figure out exactly how much in this domain is skill and how much in this domain is luck. Now the way you can write this in a model is you can say, look, let's write the outcome not as just luck plus skill, but as A times luck plus 1 minus A times skill. Now how would you unpack this? How would you figure out how big A is? What you can do is you need sort of a sequence of outcomes. And what you can see is if the same team or the same firm continues to perform well over time, then you've got to figure that A is fairly small. But if what you see is that there's huge jumps from period to period, then A is probably pretty big. So let me show you an example. Suppose that outcome equals 1/2 luck plus 1/2 skill. And suppose someone had skill equal to 1/2. Then their outcome is going to equal 1/2 luck, which is a random variable, plus 1/2. So what I'm going to see is I'm going to see sometimes they're 1, sometimes they're 1/2, sometimes they're 1/4. I'm going to see huge jumps in their outcome. Alternatively, if the payoff were different, if I could write the outcome as 0.1 L plus 0.9 skill, and their skill was equal to 1, then I'd have their outcomes equal to 0.1 L plus 0.9, and now I'd see 0.95, 0.85, 0.87, 0.92, and I'd see a much tighter distribution. So what you can do is you can figure out the relative amounts of skill and luck in a domain by looking at lots of data and looking at the performance of lots of athletes, firms, and those sorts of things. You can figure out some things are high skill, like the 100-meter dash, and other things involve maybe a little bit more luck, possibly darts. Now, why would I care about this? Well, what Mauboussin says is this. There's a lot of reasons why you'd care. One is you want to fairly assess outcomes. You don't want to be going around saying, boy, this person's so lucky, when in fact, they're actually skillful. But another important thing, we'll talk about this later in these set of lectures, is you want to recognize if outcomes depend a lot on luck, there's going to be a lot of reversion to the mean. So if somebody's won 3 times in a row, but it happens to be lucky, you shouldn't expect them to win the 4th time. If it's been mostly skill, you should expect them to win the 4th time and the 5th time and the 6th time. So understanding whether it's luck or skill is going to let you figure out whether there's going to be reversion to the mean or not. Another thing, giving good feedback. You're a manager. You see someone do really well. If you know this depends entirely on skill, you want to say, hey, boy, that's just great, and we really appreciate all the effort you're putting in, and you're doing a great job. If it's mostly luck, you want to say to that person, we know things are going well, but don't be disappointed if things don't go as well next time, because there's a lot of fluctuations, a lot of randomness in the situation. So again, giving good advice, giving good guidance is going to be helpful for you to know whether someone has basically succeeded because of skill or because of luck. And then finally, fair allocation of resources. Suppose again you're a manager, you've got 2 employees, and you're trying to figure out who should I give the big raise to? This person who had a lot of sales or the person who had little sales. If it's mostly skill, yeah, you should give it almost all to the person who had a lot of sales. If there's a huge luck component, you should go for more equal distribution of payout, because the fact is that one person probably just got lucky. So there's a lot of managerial reasons, a lot of predictive reasons why you'd like to understand whether an outcome is skill, whether it's luck. So having even a fairly basic model like this will be really useful. Now I want to get to an insight that Mauboussin makes in his book that's really profound. So we can think about some domains being high skill, like the 100-meter dash. Right? To win the 100-meter dash in the Olympics, you've got to be really, really fast. We think of these as some of the greatest athletes in the world. We think of Jesse Owens and Usain Bolt as incredibly skillful people. Then there's other domains, like playing rock, paper, scissors, where you think, okay, whoever wins that is lucky because you're just randomly picking rock, paper, or scissors. So 100-meter dash is skill. Rock, paper, scissors is luck. But what Mauboussin points out is there's something called the paradox of skill. And that is when you get the very best people competing against each other, they tend to actually have fairly similar skills. And so therefore, the winner is likely determined by quite a bit of luck. So paradoxically, when you get high-skilled people competing, less variation in skill, more luck. Let me show this through a couple examples. So suppose first I have a fairly wide spread of skill levels. So notice one person's 60, one person's 50, one person's 40. Now this is a domain where the component of skill is roughly 10 times the component of luck, right? So skill is 60, luck is only 6. So the outcomes in this case, after I add in the luck component, go right in order, 66, 55, 49. So the most skillful person wins, second most skillful person takes second, and the third most skillful person takes third. So what we get is outcomes that align exactly what we'd expect based on skill. Luck doesn't play any role. But now let's suppose I move to the Olympic Games and I take the best people in the world competing in this event. Now their skill levels are 61, 60, and 59. And now there's a little bit of luck that comes into play. And what we see is the winner actually is the third best person, because even though their skill is only 59, they happen to get a luck of 9, which gets them to 68, which is better than the other two people. So the paradox of skill is, once you get a whole bunch of people that have fairly similar skill levels, then even if there's only a small luck component, luck is going to play a large role in determining the winner. And we see this actually in sports. So in baseball, which is an American sport, one of the big awards to win is to win the batting title, to be the best hitter. So last year, Miguel Cabrera from Detroit, I'm wearing my Detroit shirt here, Miguel won the American League batting title, which was great. But notice he got hits in 34.4% of his at-bats, and behind him were two people at 33.8%. Just take away a few hits from him and add a few hits to either of these other people, he doesn't win the batting title. So was it skill that got him in the top 4? Absolutely. But it was luck that won him the batting title. That's the paradox of skill. It takes skill to get there, but once you're there, the winner, especially when it's this close, is probably going to be determined by some luck. And luckily for Detroit, Miguel won it. Well, here's another even more famous example. This is a picture of Michael Phelps. This is from CNN Sports Illustrated. This is a picture of Michael Phelps out-touching Michael Kavik in the 100-meter butterfly in the previous Olympics. And you can see, if you look really closely at this picture, that Phelps's hands are bent a tiny bit and Kavik's hands have not yet touched it. So literally, Michael Phelps beat him by a fingertip. Now, Phelps is the most decorated Olympic athlete of all time. So there's no doubt that he has a lot of skill. He has a ton of skill. But so does Kavik. Kavik has a lot of skill as well. And so the winner in this particular race happened to come down to just a little bit of luck, maybe by the tip of a finger. Okay, so what have we learned in this lecture? We've learned that in some cases you can think of outcomes as being combinations of skill and luck. And you can determine how much skill and how much luck by looking at variations in outcomes. Is there a lot of flipping, or are there sort of consistent winners? And we also then got from this very simple model a paradoxical result. The paradoxical result is that when you get all high-skilled people competing against one another, even if it's a low luck environment, luck will play a large role because of the paradox of skill. All right, so that's a luck and skill model. Now we're going to move on to a model of random walks. All right, thank you.